All right, so you're getting ready for a Microelectronics Materials Engineer interview.
That's awesome.
Pretty exciting stuff,
Yeah.
I'd say.
Yeah.
We're going to dive into RoleCatcher's Career Guide
Okay.
and their interview guide today to give you a little bit of extra help.
Right.
You can think of this deep dive as your own personal playbook.
Okay.
Not just for answering questions, but for figuring out what really clicks with those interviewers in this field.
Yeah, and this role is so fascinating. It's at the forefront of like all these innovations, right?
Yeah.
We're talking about materials that make smartphones possible, medical devices, and all sorts of technology.
Exactly.
It's really cool stuff.
Before we jump into the interview questions, though,
Okay.
let's take a quick look at the career path itself.
Sure.
RoleCatcher's Guide does a really good job of highlighting that typical progression
Okay.
from entry level all the way to,
Right.
becoming a principal engineer.
I see.
What I thought was really cool about this is they don't just list titles.
Right.
They actually provide real-world examples of what each stage looks like.
Yeah.
So you can actually see what someone with, say, 5 years of experience in this field is doing
Right.
versus someone who's been at it for 15 years.
I see.
It's like a sneak peek into your potential future.
Absolutely.
Okay, let's get to the interview questions.
Okay. Sounds good.
RoleCatcher identified some of the toughest ones you might encounter.
All right.
They also use AI to analyze job descriptions
Mm-hmm.
and tailor your answers to those specific roles, which is super cool.
That's really cool.
We'll get to that a little bit later.
Okay.
But first, let's tackle this first question.
All right.
Can you explain your knowledge of semiconductor materials?
Oh. Okay.
Seems like a pretty classic opener, right?
Definitely fundamental. Yeah. It's a
Yeah.
fundamental question. And I think, they're not just looking for you to give a textbook definition of a semiconductor. They want to see that you actually understand like the nuances of different types of semiconductors and their properties.
Yeah, okay.
Things like conductivity and band gap.
So it's not just knowing what a semiconductor is.
Right.
It's understanding how those properties actually impact its use in microelectronics.
Precisely, yeah.
Okay.
So for instance, like you could mention how silicon's band gap makes it perfect for transistors and computers.
Uh-huh.
But then something like germanium with its smaller band gap
Yeah.
is often used in high-speed electronics.
I see.
So think about weaving in those real-world applications
Okay.
to really demonstrate that deeper understanding.
Great point.
Yeah.
What if they follow up with,
Right.
how do you see semiconductor materials evolving in the future?
Ah, that's a good one.
That seems like a question that's designed to see how plugged in you are to those latest developments.
Absolutely, yeah.
Yeah.
This is your chance to talk about things like, 2D materials like graphene
Yep.
and their potential for, even smaller, more efficient devices.
Okay.
Or you could talk about the challenges, like in semiconductor manufacturing, like miniaturization limits.
Yeah.
And how, like, new materials might help overcome these.
So it's your chance to show that you're not just book smart,
Right.
but you're also aware of where the industry is headed.
Absolutely.
Okay, speaking of keeping up to date,
Okay.
another question RoleCatcher flags is, how do you stay current with the latest developments in microelectronics materials?
Right.
It's not enough to just say you read journals, right?
Not at all, no.
Yeah.
You need to be specific, right?
Yeah.
Mention conferences you attend, industry websites you follow,
Yeah.
or online communities even, where you engage with other professionals.
Uh-huh.
Think about how you learn and show that you're actively seeking out knowledge.
Okay.
You're not just passively waiting for it to come to you.
Got it.
Yeah.
Okay, next up is a question that seems to combine technical knowledge with practical experience. How do you ensure the quality of microelectronic materials?
Okay.
This one feels like it's all about showcasing those hands-on skills.
Exactly, yeah.
Yeah.
So they want to hear about your experience with quality control processes,
Right.
like statistical process control or failure analysis.
Uh-huh.
And don't just list them.
Right.
Give concrete examples, right?
Okay.
Describe a time when you spotted a quality issue,
Mm-hmm.
how you investigated it,
Okay.
and the solution that you implemented.
So let's say you used statistical process control
Okay.
to monitor thin film deposition.
All right.
Could you walk me through how that might play out in a real-world scenario?
Yeah, absolutely.
Yeah.
So you could describe how you monitored parameters like film thickness and uniformity using control charts,
Mhm.
and then explain how you would identify any like deviations from the norm
Okay.
and the steps that you would take to correct the process to ensure that quality was consistent.
Great tip.
Yeah.
Okay, now let's switch gears to the clean room, a place that seems both fascinating and a little intimidating.
Yeah.
RoleCatcher highlights the question, What experience do you have with clean room processes and protocols?
Okay.
Why is this such a crucial area to focus on?
Well, clean room environments are all about minimizing contamination.
Right.
And, in microelectronics manufacturing,
Hmm.
any stray particle can just wreak havoc. Right?
Yeah.
So they want to make sure you really understand, like, the gravity of maintaining that pristine work environment.
Okay.
Yeah.
So it's not just about knowing how to wear a bunny suit.
Right, exactly.
It's about demonstrating that deep understanding of why those protocols even exist.
Absolutely.
Okay.
So, you could describe the different clean room classifications you've worked in,
Uh-huh.
highlight specific protocols you've followed,
Okay.
and even talk about a situation where, you had to address a potential contamination issue.
Right. Big.
Show them you're proactive and detail-oriented when it comes to maintaining that clean room integrity. Yeah.
It's not just about following rules.
Right.
It's about understanding why those rules are there.
Exactly.
All right. Let's move on to another technical question.
Okay.
Can you explain your experience with thin film deposition techniques?
All right.
This seems like the perfect opportunity to really dive into those specifics of your expertise.
Absolutely. So don't just, rattle off a list of techniques.
Right.
Choose a specific project where you applied like thin film deposition,
Okay.
perhaps one that presented a unique challenge maybe,
Mm-hmm.
and describe the technique you used,
Okay.
the parameters you optimized,
Mhm.
and the results that you achieved.
For example, if you were working on a project that required a very thin, uniform coating
Oh, yeah.
on a very delicate substrate,
All right.
how would you explain your approach?
Yeah, so in that case, you could talk about your choice of a deposition technique,
Mm-hmm.
like atomic layer deposition,
Right.
which is known for its precision and control. And then you can mention like specific parameters that you optimize, like
Mhm.
temperature and pressure, to achieve that desired film thickness and uniformity.
So it's not just about knowing the techniques.
Right.
It's about showing that you can actually apply them
Exactly.
to solve those real-world problems.
Precisely.
Okay, now let's tackle a question that dives into problem solving.
All right.
Can you describe your experience in failure analysis of microelectronic materials and devices?
Okay.
This one feels like they really want to see your detective skills in action.
Right.
Hmm.
Be prepared to discuss the analytical tools and techniques that you've used.
Okay.
Things like scanning electron microscopy or X-ray diffraction.
Uh-huh.
But more importantly, walk them through a specific case
Like it.
where you investigated a failure,
Right.
explain your methodology,
Mhm.
the root cause that you identified,
Right.
and the solution that you proposed.
It's not just about identifying that failure.
Exactly.
It's about understanding the why behind it.
Yeah.
What if they follow up with, what's the most challenging failure analysis you've encountered?
Okay,
And what did you learn from it?
that's a great question.
Mm-hmm.
This allows you to highlight like your resilience
Okay.
and growth mindset, right?
Yeah.
So describe a case that was particularly complex,
Mm-hmm.
where the root cause was not immediately obvious.
Okay.
Talk about the different approaches that you tried,
Mm-hmm.
maybe the dead ends that you encountered,
Right.
and how you ultimately arrived at that solution.
So it's about showing that you can learn from both the successes
Yes,
and those setbacks.
absolutely.
Okay, before we wrap up this part of our deep dive,
Okay.
let's squeeze in one more question
All right.
that seems to be a favorite among these interviewers.
Okay.
Can you explain your experience in designing microelectronic materials and devices?
Okay.
This one feels like it's all about your creativity and innovation.
Absolutely. And here you want to showcase your ability to kind of like translate those device requirements into material specifications.
Mm-hmm.
So, talk about your design process,
Okay.
highlight your experience with simulation and modeling tools,
Uh-huh.
and emphasize your understanding of fabrication processes.
Let's say they follow up with, what are some of the key considerations when designing materials for high-performance microelectronics?
Okay.
What are some points that you would hit on?
Well, you could discuss like the need for materials with excellent electrical conductivity,
Uh-huh.
thermal stability,
Hmm.
and mechanical strength.
Okay.
You could mention the importance of compatibility with existing fabrication techniques
Right.
and like the challenges of miniaturization.
Mhm.
So this is where your knowledge of material science and your
Yeah.
understanding of those industry trends really come into play.
Okay, so we've covered a lot of ground in this first part.
Yeah.
We've tackled some of the toughest interview questions,
Yeah.
focusing on how to showcase your technical expertise,
Right.
your problem-solving skills,
Mhm.
and your passion for the field.
Absolutely. And, we've only just scratched the surface.
Right.
There's so much more to explore when it comes to these microelectronics materials engineer interviews.
You're right.
Yeah.
In part 2, we'll delve even deeper into those questions.
Okay.
And we'll provide more concrete examples to help you really craft those impressive answers.
Sounds good.
But before we move on, let's take a quick break to explore how RoleCatcher's AI can give you that extra edge in the job market. We'll be right back.
Okay.
Welcome back.
Okay, so we've started unpacking some of those tricky interview questions.
Yeah.
But let's dive even deeper
Okay.
into how you can really nail those answers.
Right.
Because it's one thing to know the concepts, right?
Right.
But it's another thing to be able to articulate them
Yeah.
clearly and persuasively
Yeah, for sure.
in that interview setting.
And that's where I think like RoleCatcher's AI tools can be really helpful
Okay.
because they analyze job descriptions.
And they can pinpoint those specific skills and keywords
Okay.
that employers are looking for.
It's like having a secret decoder ring
Yeah,
for job postings.
exactly.
So how does this actually help you craft better answers?
So think of it this way. You're essentially speaking the employer's language,
Okay.
right? By incorporating those keywords and highlighting the specific skills they've emphasized in the job description,
Right.
you're showing them that you've done your homework
Okay.
and that you understand their needs.
So it's about tailoring your answers to what they're actually looking for,
Precisely, yeah.
not just giving a generic textbook response.
Exactly.
Okay. And RoleCatcher's AI can even help you refine your delivery.
Oh, wow.
You can record practice answers, and their AI will analyze your tone,
Okay.
your pacing, your content,
Wow.
and then provide personalized feedback to help you sound more confident and articulate.
That's awesome.
It's like having a virtual interview coach.
Yeah, that's really cool.
Okay, let's get back to those tough questions.
All right.
We left off with the question about designing microelectronic materials and devices.
Okay.
Do you have any more tips on how to approach that one?
Yeah, so remember, the key here is to really showcase your ability to kind of bridge that gap
Okay.
between theoretical knowledge and practical application.
Right.
So you could mention like specific design challenges that you've encountered, perhaps related to material compatibility or fabrication limitations,
Okay.
and explain how you overcame them.
Right, so it's about showing that you can think critically and creatively
Exactly.
to solve those real-world engineering problems.
Absolutely.
Okay, now let's revisit that question about ensuring the quality of microelectronic materials.
Okay.
This is where your understanding of those quality control processes really shines.
Yeah.
So beyond just listing those processes like statistical process control and failure analysis, what kind of details would make your answer stand out?
Specificity is key, right? Choose a specific project.
Where you played a key role in quality assurance.
Okay.
Describe the challenges you faced, the specific techniques you employed,
Right.
and the metrics you used to measure success.
For instance, if you were working on a project that involved the fabrication of integrated circuits,
Okay.
how could you demonstrate that knowledge of quality control?
You could talk about how you implemented like a really rigorous statistical process control system to monitor critical parameters like line width, layer thickness, and defect density.
Okay.
Right? And explain how you use data analysis to identify trends,
Right.
pinpoint potential issues,
Okay.
and implement those corrective actions.
So it's about showcasing those analytical skills
Absolutely.
and your ability to use data to really drive that quality improvement.
Precisely.
Okay, now let's switch gears back to the clean room.
Okay.
It's such a unique and crucial aspect of this whole microelectronics manufacturing process.
It really is. And interviewers want to know that you not only understand the protocols,
Right.
but that you genuinely appreciate the importance of maintaining that contamination-free environment.
Absolutely, because like we said, even a tiny speck of dust can spell disaster for a microchip.
Right, exactly.
So when you're answering that question about your clean room experience, don't just focus on the rules.
Okay.
Share an anecdote that illustrates your commitment to maintaining those standards.
For example, could you describe a time when you had to address a potential contamination issue, even if it seemed minor?
Yeah, for sure. You could talk about a time when you noticed a colleague not following the proper gowning procedures, or perhaps like a piece of equipment that wasn't properly cleaned.
Right.
And explain the steps that you took to address the situation and prevent that potential contamination.
It shows that you're proactive
Absolutely.
in maintaining that pristine work environment. Okay, now let's delve back into the world of semiconductor materials.
Right.
We talked about explaining your knowledge of these materials.
Yes.
But what if they ask you a more specific question?
Okay.
Like, what are the advantages and disadvantages of using silicon as a semiconductor material?
Ah, that's a classic.
Mm-hmm.
So that really tests your understanding of silicon's unique properties.
Okay.
So you could highlight its abundance,
Uh-huh.
low cost,
Okay.
and like the well-established fabrication processes as advantages.
Right. Silicon is pretty much the workhorse of the semiconductor industry,
Yeah,
but it must have some limitations, right?
of course. Yeah.
Yeah.
So you can mention its relatively low electron mobility,
Okay.
which limits its performance in high-speed applications,
Mhm.
and its indirect band gap,
Right.
which makes it less efficient for like light emission
Okay.
compared to materials with direct band gaps.
So it's about acknowledging both the strengths and weaknesses
Oh, that's-
of this really widely used material.
Absolutely, and that kind of balanced analysis
Yeah.
is something that interviewers really appreciate.
Okay, now let's tackle another question that comes up often.
Right.
Can you explain your experience with thin film deposition techniques?
Okay.
This seems like the perfect opportunity to highlight your expertise
Yeah.
in a specific area of material science.
It is, and again, specificity is key.
Right.
So choose a project where you applied a particular thin film deposition technique,
Okay.
perhaps one that presented a unique challenge
Mhm.
or required a high level of precision.
For example, if you were tasked with creating a very thin, uniform coating on a complex 3D structure,
Okay.
what deposition technique might you choose and how would you explain that approach?
In that scenario, atomic layer deposition, or
Yeah.
ALD, would likely be the best choice
Mm-hmm.
due to its ability to deposit those highly conformal and uniform films, even on complex geometries.
Yeah.
And then you could discuss the specific parameters that you optimized, like precursor selection,
Okay.
temperature,
Right.
and pulsing sequences, to achieve those desired film properties and conformality.
So it's not just about knowing the technique, it's about showing you can tailor it
Exactly.
to meet those very specific project requirements.
Precisely. And remember,
Yeah.
interviewers are often looking for candidates who can think critically, solve problems,
Right.
and communicate their ideas
Yeah.
clearly.
Okay, let's move on to a question that really tests those problem-solving abilities.
Okay.
Can you describe your experience in failure analysis of microelectronic materials and devices?
All right, so this is your chance to, showcase your detective skills.
Right.
Think of a failure analysis case
Mm.
that you found particularly challenging,
Okay.
intriguing.
Right, because it's not just about identifying the problem.
Exactly.
It's about that journey
Yes.
of uncovering the root cause.
Absolutely.
So walk the interviewer through your step-by-step process.
Okay.
Highlight the analytical techniques you used,
Mm.
the challenges you faced,
Right.
and the insights you gained along the way.
So let's say you were investigating a sudden decrease
Okay.
in the performance of a semiconductor device.
Mm-hmm.
How would you approach the analysis?
Okay, well, you could start by describing your initial observations. Perhaps you noticed an increase in device resistance
Okay.
or a change in its electrical
Oh,
characteristics.
great.
And then you could explain how you used various analytical techniques
Mm-hmm.
like scanning electron microscopy
Okay.
and energy dispersive X-ray spectroscopy
Uh-huh.
to really examine that device at the microscopic level.
Right.
So you're painting a picture of your systematic approach,
Yes.
using those different tools to gather the evidence.
Absolutely.
What kind of details would really make this answer stand out?
You could describe specific findings,
Okay.
right? Like the presence of a contaminant or a defect in the device structure.
Right.
And explain how you use those findings to narrow down
Okay.
the potential root causes and eventually pinpoint the culprit.
So it's about showcasing your ability to connect the dots, analyze the data,
Mm-hmm.
and draw those meaningful conclusions.
Absolutely. And that kind of analytical thinking is
Yeah.
so valuable
Right.
in the field of microelectronics.
Okay. Now let's shift our focus to a question that often trips up those candidates.
Okay.
Can you explain your experience in designing microelectronic materials and devices?
All right.
This one can feel a bit daunting,
It can.
especially if you're earlier on in your career.
Yeah.
Do you have any tips for making that answer stand out,
Mm-hmm.
even if you don't have years of design experience?
Yeah, so remember, like, the emphasis here is on your understanding of the design process
Hmm.
and your ability to think creatively.
Right.
So you could discuss your experience with simulation and modeling tools,
Okay.
highlighting how you've used them to test different design
Yeah.
concepts and optimize those material properties.
For example, if you were designing a new type of transistor, what considerations would you take into account?
Well, you definitely consider factors like the desired operating frequency,
Okay.
power consumption,
Hmm.
and integration density.
Okay.
And you could explain how you'd use simulation tools to like model the device's performance
Right.
under different conditions and explore various material combinations
Uh-huh.
to optimize its characteristics.
So even if you haven't designed a complete device from scratch,
Right.
you can still demonstrate that you understand the design principles
Exactly.
and that you can think creatively.
Absolutely.
And don't be afraid to discuss any personal projects or research
Yeah.
that you've done outside of your work.
Yeah, definitely.
Shows initiative
Yeah, absolutely.
and a genuine passion for the field.
For sure.
Okay, before we move on to the final part of our deep dive,
All right.
let's talk about how RoleCatcher's AI can be a game changer
Okay.
in your job search.
I think so too.
We've already talked about how their AI analyzes job descriptions
Mm.
to help you tailor your answers.
Right.
But it goes beyond that.
Oh, wow.
They also have tools that can actually analyze your resume
Really?
and suggest improvements to make it more appealing to both human recruiters
Okay.
and those AI-powered screening systems.
That's really cool.
It's like having a personal branding expert for your resume.
Yeah, it really is.
Their AI can identify keywords,
Okay.
highlight your most relevant skills,
Mm-hmm.
and even suggest formatting improvements to make your resume stand out from that crowd.
Wow, that's awesome.
Okay, so I'm definitely seeing the value in this.
Yeah.
It's not just about having the right qualifications.
Right.
It's about presenting them in a way
Exactly.
that really captures that attention.
Absolutely. And in today's competitive job market,
Mm-hmm.
every advantage counts.
Great point.
Yeah.
Now, I'm eager to hear more about those final tips for acing the interview.
All right.
Let's jump into part 3
Okay.
and wrap up this deep dive. Okay, so we've covered a ton of ground, from understanding the role itself to tackling those tough technical questions.
Yeah.
Now let's talk about those finishing touches.
Okay.
The things that can really make you shine in that Microelectronics Materials Engineer interview.
Right. So we've prepped for the content.
Yeah.
Now it's time to focus on the delivery.
Okay.
Think of it like this. You've got the raw materials.
Uh-huh.
Now it's time to craft them into a masterpiece.
I like that analogy.
Yeah.
So beyond just knowing the answers,
Okay.
what can you do to project confidence and make that lasting impression?
First, remember that an interview is a conversation.
Okay.
It's not an interrogation.
Right.
It's about connecting with the interviewer,
Mm-hmm.
showcasing your personality,
Yeah.
and letting your passion for the field really shine through.
So it's not about being a robot
Right.
who recites memorized answers.
Exactly.
It's about being authentic
Yes,
and engaging.
absolutely. And that starts with your mindset.
Okay.
You know, go in with the belief that you have something valuable to offer.
Right. You've worked hard to get here.
Mhm.
You've got the skills, you've got the knowledge,
Yeah.
and you're excited about the opportunity.
Confidence is key.
Yes.
But how do you project that confidence, especially if you're feeling those pre-interview jitters?
Preparation is your best friend.
Okay.
The more you practice, the more confident you'll feel.
Mm-hmm.
And don't just practice the answers.
Right.
Practice the entire interview experience.
Okay.
Mock interviews with friends or mentors can be incredibly helpful.
It's like rehearsing for a play, right?
Exactly.
The more you rehearse, the more comfortable you'll be on stage.
Right.
Or in this case, in the interview room.
Exactly. And don't underestimate the power of body language.
Okay.
Sit up straight, make eye contact, speak clearly and enthusiastically.
Okay.
These nonverbal cues really convey confidence and engagement.
Okay, so we've got the confidence piece down.
Okay.
What about those curveball questions that interviewers love to throw?
The ones that seem to come out of left field
Right.
and really test your ability to think on your feet.
Those can be tricky.
Yeah.
But remember, the interviewer isn't necessarily looking for the right answer.
Okay.
They're often more interested in seeing how you approach a problem, how you think critically, and how you communicate your thought process.
So if they ask something like, if you could have dinner with any 3 scientists, dead or alive, who would they be and why?
Okay.
It's not about naming the most famous scientist.
Right, exactly.
It's about showing your intellectual curiosity, your ability to connect different ideas, and your passion for the field.
Maybe you choose someone who pioneered a key concept in microelectronics,
Okay.
someone who's doing cutting-edge research today,
Right.
and someone from a completely different field
Okay.
that inspires you.
That's a great example.
Yeah,
It shows that you're a well-rounded thinker
absolutely.
who can draw inspiration from all these different sources.
For sure.
Okay, now let's talk about the closing moments of the interview.
Okay.
What are some things you can do to leave a lasting positive impression?
First and foremost, express your genuine enthusiasm for the role in the company.
Okay.
Let them see that you're really excited about the opportunity.
Right, because passion is contagious.
Absolutely.
Yeah.
And ask thoughtful questions.
Okay.
This shows that you've done your research, you're engaged,
Right.
and you're genuinely interested in learning more.
So what kind of questions would you recommend?
You could ask about specific projects that the team is working on,
Okay.
the company's culture and values,
Mm-hmm.
or even their vision for the future of microelectronics.
Okay.
Avoid asking questions that you can easily find the answer to online.
Right, you want to show that you've gone beyond that basic research.
Exactly.
And that you're truly curious about the inner workings of the company.
Absolutely.
Okay, now what about following up after the interview?
Okay.
Is a thank you note still necessary in this digital age?
Absolutely. A well-crafted thank you note
Okay.
can really make you stand out
Mm-hmm.
and reinforce your interest.
Okay.
Reiterate your enthusiasm,
Uh-huh.
highlight a key point from the conversation,
Right.
and express your gratitude for their time and consideration.
Okay, so we've talked about projecting confidence,
Yes.
handling those curveball questions,
Mm-hmm.
and making that strong final impression.
Absolutely.
Any final words of wisdom
Mm-hmm.
for those who are about to embark on this Microelectronics Materials Engineer interview journey?
Remember, this is your chance to shine.
Okay.
Showcase your passion, your expertise,
Mm.
and your unique personality.
Yeah.
Let them see why you're the perfect fit for the role.
I love that it's not just about getting the job.
Right.
It's about finding the right opportunity
Exactly.
where you can really thrive.
For sure.
Okay, we've covered so much ground in this deep dive,
We have.
from the nitty-gritty technical questions to the finer points of that interview etiquette. And don't forget the power of RoleCatcher's AI tools
Yes.
to help you tailor your answers, refine that resume,
Mm-hmm.
and gain that extra edge in the job market.
It's a game changer.
Right, RoleCatcher can be your secret weapon in this whole process.
For sure.
So to all of you out there who are preparing for that big interview,
Yeah.
do your research, practice your answers,
Mm-hmm.
and most importantly, believe in yourself. You've got this.
You got this.